Okay, hi everybody. So this is a review over sections 13.1 to 13.4. What I'd like you to do for this is get out a separate sheet of paper. There's no new notes or anything like that. All I'm going to do is I'm just going to go through some problems. I'm going to start by showing you the problem. I'd like you to pause and then do the problem and then watch the work, check your answer, make sure you're getting it right. If you can follow along with everything here and know what you're doing with all of these problems, you'll be good for the quiz. Quiz is again going to be on, I'm going to post it on Thursday. I'll post the review key video on Wednesday. The video will cover the assignment that you'll have for tonight. And then the quiz will be opened up on Thursday morning. For those of you taking, I know you probably already heard me say this in the intro video, but for those of you who are taking the A-Push test, we decided to put this on Thursday so you could take your A-Push test on Friday. If there's anybody taking the AP Physics test, any of you juniors taking the AP Physics test, and you don't want to take your quiz on Thursday, email me and let me know, and I can just let you take that on Friday. But make sure you tell me ahead of time. Other than that, let's get started. Okay. All right. First question here. Again, go ahead and pause and then play when you think you've gotten the answer. Find the values of the 6 trig functions for theta. Okay, so I'm going to first start off by writing out all of the 6 trig functions. We've got, we're going to do sine theta, cosine theta, and tangent theta. Remember, they're reciprocals. That's why I say 6 here. The reciprocal of sine is cosecant. The reciprocal of cosine is secant. And the reciprocal of tangent is cotangent. Okay, so the first thing that I need to do is I need to find this missing side length, right? So let's call this A. A squared plus 4 squared equals 6 squared. So A squared plus 16 is 36. I subtract away the 16, I get A squared is 20. And then, so A is radical 20. Make sure you put it in simplest radical form. No decimals, no decimals. Should have written that probably in the directions. But square root of 20 would be 2 radical 5. Okay. So I'm going to erase this and put 2 radical 5. Okay. All right. So that means the sine of theta, the opposite over hypotenuse would be 4 over 6. 4 over 6 or 2/3, which means my cosecant theta would be 3/2. My cosine theta would be the adjacent over hypotenuse. So 2, oops, why did I write A? Weird. 2 radical 5 over 6. Reduced to radical 5 over 3. Now, when I make that secant theta, I would be saying 3 over radical 5, but then we have to rationalize the denominator to make that 3 radical 5 over 5. And that's my answer. Tangent theta would be opposite over adjacent. So 4 over 2 radical 5, reduce out the 2. So it'd be 2 over radical 5, rationalized to 2 radical 5 over 5. Now, when I go to find cotangent theta, I'm just going to go reciprocal of this one. So this would just be radical 5 over 2. So I don't have to re-rationalize or anything like that. Okay, so there's number 1. Okay, why don't you go and find, use the special right triangles to find x and y for both 2 and 3 here. Go ahead and pause and play when ready. All right, so notice that number 2 is the 30, 60, 90 triangle. Again, the first thing you always want to find is the side across from the 30. So what am I given here? I'm given the 60 side, right? This is the 60 degree, so this would be considered the 60 side, the long side. So if I'm got a long side and I'm long leg and I'm looking for the short leg, I've got to divide. I've got to make it smaller, so I've got to divide. So I'm going to take 18. I'm going to divide it by my radical 3, which would be 18 radical 3 over 3 when I rationalize to make it 6 radical 3. So there's 6 radical 3. The relationship to the hypotenuse in the 30 side, sorry, that would be y is equal to. The relationship between my hypotenuse and my 30 side is double. It's the 1 to 2 relationship. So instead of 12 radical, or sorry, instead of 6 radical 3, it would be 12 radical 3. Right, and the 45, 45, again, the relationship from the leg to the hypotenuse is the radical 2, right? So it's side radical 2. Notice that x and y are going to be the same here because they're both the legs of the right triangle, and it's a 45-45 isosceles, right? So I'm going to divide by radical 2, which when I rationalize should be 9 radical 2 over 2. Again, no decimals. No decimals. All right. Here's number 4. Again, pause and then play when ready. Okay. Looks like we've got a right triangle here where theta is 70. And I want to find how long does the wire need to be? Okay, we'll call that C because it's the hypotenuse. So I know that I want to find the hypotenuse, and I'm given the adjacent side. So I'm going to use cosine. Right, so cosine 70, cosine of 70 degrees is equivalent to 6 over C. Put this over 1 and cross multiply. 6 is equal to C cosine 70. And then I divide 6 divided by cosine 70 is going to be my C value. So I go to my calculator, open that up. Make sure your calculator's in degree mode. Remember, we didn't know it yet, but it matters what the mode is. If you're going to be inputting radian measures, make sure you put make it be in radian mode. If you're going to input degrees, make sure it's in degree mode like this is here. All right, so it's going to be 6 divided by cosine 70. Okay, 17.5 to the nearest foot, 18 feet. Okay, there's my answer. Here's number 5. Go ahead and try it and then play when ready. Okay, the angle of depression from a watchtower to a forest fire is 8 degrees. Okay, let's draw a watchtower. Let's get creative here. Here is my watchtower. Looks like a tripod. There's my roof. Okay. Here's my dude. You get the gist? Fire. Okay, so the angle of depression from the tower to the forest fire. So here he's looking out. Here is the line of sight, right? And then, so here's my right triangle. I should really put that on the ground, but that's okay. Here's my right triangle. Remember that the angle of depression is the one that is made with the horizon line to the line of sight. So here is my theta, which again, alternate interior angles means this is my theta. Right? Angle of depression is equivalent from here and here. So if I'm looking down at the angle, down to something, angle of depression, it's the same as the angle of elevation down here. So there's my theta. Don't put it in here. Right? This is not theta. Don't do that. Okay. So angle of depression is there. I know if the watchtower is 25 meters high, this is 25 meters. What is the distance between the base of the tower and the fire to the nearest meter? X. Okay, so I know that this is 8 degrees. So I know I'm going to have to use tangent. Tangent of 8 degrees is equal to the opposite, 25, over the adjacent x. Okay, cross multiply and divide, we're going to get 8. X is equal to 25 divided by tangent 8. Okay, let's go to my calculator and plug that in. 25 divided by tangent 8 degrees. Just make sure it seems logical. Right? Yeah, this does seem logical. 170 to nearest meter, 178 meters. Okay. All right. Here's 6 and 7. Go ahead and pause and then play when ready. Okay, 195 degree angle. Remember that if I'm drawing angles in standard position, you can do that whole swirly thing that I showed you, but you don't need to. Here's 180 degrees out here. Well, remember, always make your initial side, and then 180 degrees is here, so 195 is just about 15 degrees more. What am I looking here? I'm looking for, is it generally in the right spot within the correct quadrant? That's really what I'm looking for there. Negative 450 degrees. Okay, so here's my initial side. Remember, negative rotation is going to go around this way and then, so here's 360 plus another 90. So this is a, you know, if you wanted to do the whole swirl, that's a negative 450 degree rotation. Okay. All right. Here's number 8. Go ahead and pause. Did I skip one? No. There's 8. Go ahead and pause and then play when ready. All right, find the measures of a positive and negative coterminal angle. So remember, for positive and negative coterminal angles, all you're going to do is just add or subtract 360 degrees. So if I'm at 382, if I subtract 360, I'm still going to get a positive angle, 22 degrees, right? So I take 382 minus 360. I still get a positive angle. So there's my positive angle. And then if I subtract 360 more, I'm going to get negative 338 degrees. So there's my positive and negative coterminal angle. Could you have said other options? Of course. You could keep adding or subtracting 360 till whenever. But that, you don't really need to do that. You just do it once. Okay, here's 9, 10, and 11. Go ahead and pause, then play when ready. Okay, so for an angle such as this one in the first quadrant, the actual angle is my reference angle. So 84 degrees here. That's my reference angle. Because remember, a reference angle is the angle made with the x-axis and the terminal side. So looking at 127 degrees here, this one's in the second quadrant. This is going to be about right there, 127 degrees, right? So there is my reference angle. This. Okay, so logically reason it through. This full rotation over to the other side of the x-axis is 180. So I'm going to take 180, and then I'm going to subtract away 127. So let's go to our calculator here. 180 minus 127 gives me 53 degrees. So that's my reference angle. And then we do the same thing here. This is a negative rotation. This is a negative 105 degrees. So this is negative 90. So here, this is my theta, right? So a negative full rotation would be 180 degrees. So I'm going to take 180, negative halfway round rotation, sorry. Negative 180 degrees, and then we'll subtract away 105, but really I'm just taking 180 minus 105. That's going to have the same, that theta there that I need. So 180 minus 105 is 75 degrees. So again, how do you find reference angles? Basically, you just graph the angle, find where the terminal side ends up. Based on what quadrant it's in, you're going to have to add or subtract 180 or 360. You just have to logically reason it through. Remember that the reference angle should always be positive. That's a mistake that people often make, try to make them negative. Reference angles are always positive, and they are always made with the terminal side and the x-axis, never the y-axis, the x-axis. Okay. Here's 12. Go ahead and try this one. This one's a little bit difficult, so go ahead, give it your best shot, and then we'll see how it goes. Okay, first thing I want to do is plot the point. So, you know what? I don't need a full axis here. 8 comma negative 3. Where is that? Oops. 8 comma negative 3. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. So somewhere out here, there is point P. Okay, so here is my angle. Point P is on the terminal side of theta. Now, remember that theta is going to be your reference angle. So you make yourself and remember, reference angles are always formed with the x-axis, never the y-axis. So here's my right triangle that's made. This is positive 8. This is negative 3. So I'm going to find the 6 trig functions with this right triangle. Okay, first thing I've got to do is find my C value. I think we called it the R value when we were doing it in the notes, but it's just the hypotenuse of a right triangle, so call it C. Okay, so this is 9 plus 64 is equal to C squared, so 73 is C squared. Yeah, don't make sure when you square that negative, it's a positive 9, not negative 9. So 9 plus 64, and then that's, that's 73. And then that is not a perfect square. Is there any perfect squares that go in there? I don't think so. 73 prime. Yeah, 73 is prime. So we're just going to call that the square root of 73. Okay. All right, now at this point, I find the 6 trig ratios, just like I do in my very first problem. We're going to find sine theta, we're going to find cosine theta, we're going to find tangent theta, and we're going to find cosecant theta, we're going to find secant theta, we're going to find cotangent theta. Okay, so sine theta is the adjacent over hypotenuse. So it's the 8 over the radical 73. And when I go to rationalize, this is 8 radical 73 over 73. Cosine theta is the opposite over, oh, shoot, sorry. That should have been cosine. You're probably thinking, wait, Mr. Laverick, you got that mixed up. That was the adjacent over hypotenuse that I just did. So that was actually cosine. Opposite, the -3, that's sine over radical 73. So that would turn into -3 radical 73 over 73. And then my tangent theta is going to be -8 over, or sorry, -3 over 8. Now, when I go to flip it for my cosecant, so I'm going to go back here and flip it. So this is going to be radical 73 over -3. This is going to be radical 73 over 8. And this is going to be 8 over -3. Okay. All right. Okay. Sorry, I wanted to pause there for you to write it down if you needed to. Okay, here's 13 and 14. This is changing from the degrees to radians and back again. Okay, so remember the conversion factor is multiplying by either pi over 180 or 180 over pi. So 400, I'm going to multiply by pi over 180. So that means I've got to reduce down this 400 over 180. Easy way to do that is just take 400 divided by 180 in your graphing calculators and then put it to a fraction. That'll give you the improper fraction to use. 20 pi over 9. There it is. And then we got negative pi over 9. So now that's in radians. I'm going to take the pi out. So multiply by 180 over pi. That will cancel the pi's here, which is basically leaving us negative 180 divided by 9, so negative 20 degrees. Okay. All right, use a reference angle to find the exact value of the sine, cosine, and tangent for each angle measure. Now, at this point, make sure you know that you will be allowed to use the unit circle on your quiz. I actually have it PDF'd on the end of your quiz. So you will be allowed to use the unit circle. Please use the one that I'm providing for you. Don't use one that you're making because I don't want anything else written on it. Use the one that's on your on the document, okay? And I've got it for you already preloaded there for you. So you don't even need to print it out or anything. It's just on the screen there for you. All right, so negative pi over 3. First thing that I want to do, actually, I don't even have one up. Okay, let me get a unit circle. No unit circles there, really. Shame. It should be here. Okay. Anyway, okay, so let's find negative pi over 3. So it should be down here, right? Negative pi over 3 should be this one. This is the, it's like negative 60 degrees, right? It's going to act like that as well. So that's what I'm going to look for. I'm going to find sine, negative pi over 3, cosine, negative pi over 3, and then tangent. Right? Okay. So let's get to our units. This is the one that I provide for you. So negative pi over 3 is negative right here. So this is the one I'm looking at. Okay. So 1/2 comma negative radical 3 over 2. 1/2 comma negative radical 3 over 2. Okay, so remember cosine is the x value, sine is the y value, and then tangent is y divided by x. Negative radical 3 over 2 divided by 1/2. So that would give me negative radical 3 over 2 times opposite, or sorry, excuse me, reciprocal. So there's a negative there. Negative radical 3 over 1, or just negative radical 3. Okay. Again, no decimals there. I realize you could go into your calculator and say, okay, I'm going to put it into radian mode because I'm going to input radians, and you can do this, right? This is okay to do, but unfortunately, sine of, if I say negative pi over 3, it's just going to spit out to you a decimal. When you try to go put it into a fraction, it's not going to do it. Why? Because negative radical 3 over 2 is irrational. That's why I'm not going to be accepting decimal answers here, because you could just potentially just put it in your calculator without even knowing what you're doing. So no decimal answers, because this is irrational. I need to know the exact radical form of it. Okay. Circle, sorry, here's 16. Go ahead and pause and then play when ready. Circle has a radius of 16 inches to the nearest inch. What is the length of an arc of the circle that is intercepted by a central angle of 80 degrees? Okay, so it almost gives us everything that we need. The only problem is this 80 degrees is in it's degrees, not radians, because we know the formula is S is equal to R theta. That's arc length. S being the arc length is equal to the radius times theta in radians, right? So all we have to do is just change 80 into radians. So it's 80 pi over 180. Cancel out the zeros. 8 pi over 18. That'd be 4 over 9. 4 pi over 9. So this means it's S is equal to R, which is 16 inches, times theta, 4 pi over 9 radians. So I go to my calculator here. So 16 times 4 pi over 9. I don't need to put it in parentheses here because I'm doing all multiplication right there. 22.3. 22.3 inches. Oh, to the nearest inch. 22 inches. There you go. Right. Okay, so find all possible values of the expression. All possible values. I'm going to underline all there. So go ahead and do that one. All right, I'm going to put it into degrees, and I'm going to put it in radians, because it all depends on what I ask you on the quiz, and I'm not going to tell you. I'll tell you on the quiz, but I honestly don't know what I ask you here, whether it's degrees or radians. So for this, I go back to my unit circle, and I want to find, since sine is the y value, I want to find where the y value is negative radical 2 over 2. So I want to find where the y value is negative. So y values are negative in the third and fourth, radical 2 over 2, and that's my 45 family here and here. So 225 and 315. 225 and 315. And remember, plus 360n. Oops. Because we have to account for all rotations. All coterminal angles will have the same sine value. And if I wanted it in terms of radians, well, that's 5 pi over 4 and 7 pi over 4. So 5 pi over 4 and 7 pi over 4. Plus 2 pi n. Remember, account for all rotations. If you wanted to get fancy, you could say where n is an integer. I'm assuming we can just say that n just accounts for any number, any whole number, any integer, really. All right, now what's different about 17 as opposed to 18 and 19? Lowercase capital S, or sorry, lowercase s here, capital S here, capital T here. What does that mean? That means I'm restricting the domain because I want it to be a function. So remember, this sine restriction is negative 90 to positive 90. Sorry. Yeah. The cosine, oops, drew a big circle there. I don't want that. Cosine is 0 to pi, or 0 to 180. And then tangent is negative 90 to positive 90, negative pi over 2 to pi over 2. So sine restrictions here, negative 90 to positive 90. Give your answer both radians and degrees. Okay, so radians. Now I'm only going to get one answer here, right? So where is it going to be? Where is my y value? Sine y, negative 1/2. Okay, so negative 1/2. And I'm only looking on the right side. I know it occurs again on the left side, but I'm only looking at the right side because that's the restricted domain. Right there. Okay, so 330 degrees, or 11 pi over 6. So 330 or 11 pi over 6. Okay. Now, I'm not going to box that answer. And I'm not going to box that answer because remember that the sign restricted is negative 90 to positive 90. Right? That is not within negative 90 to positive 90. I have to think about what is the coterminal angle that exists with 330 that fits within that domain. Well, 330 degrees, that would be negative 30 degrees. That's the coterminal angle that fits within negative 90 to positive 90. And remember, I could also treat it as negative pi over 2 to pi over 2. Which means this would be negative pi over 6, I believe. Yeah. Okay. And that's my answer. That's my restricted domain. Now in tangent, now notice here that the tangent is positive. Where is the tangent positive? First or fourth quadrant? First quadrant. And I know that because this is a positive positive. Positive divided by positive would stay a positive. I just have to figure out which one's going to be the radical 3 over 3. Thinking back, didn't I just do a problem like this? No, it wasn't here. I found the tangent. Okay, the tangent of a 60 family was just radical 3. So it's got to be the 30 family that's going to be the radical 3 over 3. I know it's not the 45 family because the 45 family would be the tangent of 1. Or the tangent is 1. So it's got to be the 30 family. So let's just double check that. So 30 family within the first quadrant. 30 family within the first quadrant. Okay, well, that's just 30 degrees. What am I thinking? That's pi over 6. So this is, pi over 6 or 30 degrees. Okay. If I wanted to double check that again, the cosine, so the coordinates are radical 3 over 2 and then 1/2, right? That's my 30 family within the first quadrant. So if I take y over x, it's going to be 1/2 divided by radical 3 over 2. So which is 1/2 times 2 over radical 3. And then when I cancel out, this will indeed make me rationalize to radical 3 over 3. That's why I know there's my tangent with the 30 family. Okay, pi over 6 and positive 30 degrees. All fitting within my domain. I don't have to do anything funky here because it fits within my domain. My domain is negative 90 to positive 90. Right? So 30 and pi over 6 fit within that domain. Okay, try this 2 more times. Okay, so my cosine being negative 1. Now think back. Where is my cosine negative 1? Where's my x value negative 1? There's only one spot right here. 180 pi. 180 degrees or just pi radians. Okay, sine value being radical 2 over 2. Sine radical 2 over 2. Okay. Y value right there. Right here. Right? Not down here. Up there. Because that's negative. And it's not over here. I know you see it right there, but remember, sine is restricted to right here and here. So it's my 45 degrees. Or pi over 4. And again, I don't have to do anything funky with that one because it still fits within my domain. Okay, a couple more here. Here's 22. Go ahead and pause and then play. All right, here's a skateboard ramp. Skateboard ramp is 39 inches long. I would assume that they're counting this. That's my diagonal length. And it rises to a height of 22 inches. Assuming that's right here. To the nearest degree, what is the angle of the ramp? Okay. Well, this is sine. Sine theta is going to be opposite 22 over hypotenuse 39. So theta can be calculated by taking inverse sine of 22 over 39. Let's go to my calculator here. Inverse sine of 22 over 39 gives me, that's in radians. Since it's a really small decimal, I know it's going to give it to me in radians. Let's put it back into degree mode. I want my calculator to spit out degrees instead of radians. And run that calculation again. 34 degrees is a little bit better. 34 degrees. Up to the nearest degree. Yeah. All right. I know a lot of people are asking some questions on these, so I'll try to do the best I can with explaining here. Notice that 23 and 24, again, I'll give you time to pause. Okay, notice that 23 and 24 are the exact same problem, just one has a different restricted domain, right? Okay, so what is theta here? Well, I go to my calculator and I find inverse sine of 0.3. And the calculator spits out, and again, the calculator, remember, is only giving you restricted domain, 17.5. 17.5 degrees, okay? Now, is 17.5 within that domain? Yes, it is. It's between negative 90 and positive 90, so that's my answer. However, my calculator is still only going to give me 17.5 here, but that is not within this domain. So I've got to think about where else is the sine value 0.3, okay? Now, think about sine is the y value. So since sine is right here at 0.3, say this is 1, right? This is 0.3. So there's an angle here at 17.5 degrees, but there's another place in the unit circle right there that also has the sine of 0.3. Now, what is that angle? Remember the reference angles. Let me change colors here. The reference angles are always congruent. So those are congruent. So what is this full angle? This 180 minus that 17.5 reference angle. So let's see what that is. 180 minus 17.5 gives us 162.5. Is that within my domain? Yes, that's within the restrictions. Good. Okay, so let's take a look here. Again, same problem, right? Same problem. I'm just doing different restrictions on it. Okay, so let's run the calculation. Let's find out what theta is going to be. Inverse tangent of 2.2. Oh, that's just 0.2. Excuse me. 2.2. Gives me 65 I think it said to round it to the nearest tenth. So, oops. Yeah, round it to the nearest tenth. So 65.6 degrees, right? Now, is that within this domain? Yes. Right, so 65.6 degrees. Now, the calculator is only going to give me this 65.6 again. Now, for sine and cosine, you think about x value, y value. Cosine is x, sine is y. Tangent, you have to think about whether this is positive or negative. Since this is positive, remember that the only other place where tangent is positive here, it's negative here, it's positive here, it's negative here, right? Because you got to think about positive divided by positive, negative divided by positive, and so on. So the only other place it's positive is down here. So we've got a 65.6 degrees reference angle matching down here. So those two reference angles are congruent. So where does this end up? This is 180 plus 65.6, just logically reasoning through 180 plus my reference angle of 65.6 degrees. And that's going to get me 80 plus 65.6 to 45.5, which fits within this domain. If I calculated an angle and it still didn't fit within my domain, then you would say no solution there. Like if this had come out to be, I don't know, 280, not within my domain, you'd have to say no solution. But since it fits, it's good. All right. So hopefully we're all having a good day, and I'll talk to you all later.